now we're talking about the rotor. So remember earlier I said we redesigned the stator, we redesigned the rotor. Well, the rotor, we had a couple options. We could keep the coil design, rewind it and duplicate it. That's what uprate 1 is. Or we could come up with a new design because we've just felt like we could maybe improve this machine, and that would be uprate 2. And I'm just highlighting a few things, but the most important thing to know was the temperature. If I kept the original, the temperatures of the field coil, field hotspot at unity power factor of 0.95, and then the proposed new one, you can see there's a temperature differential. I'm going to just round it up and say about 10 degrees C. Might not seem like a lot, but it's a lot in insulation. It's a lot in design. And one of the things that's most important is that the life of the motor is, or the insulation system, is inversely proportional to temperature. So if the temperature goes up, the life goes down. So using that simple principle, I said, you know, there's only one design here. It's going to be the one that operates cooler. Well, that still was a challenge because we then had to take that and go, will that even fit the poles with the layering and the turns that we needed? So a CAD drawing was done of the rotor, of the coils mounted on the spider. And in particular, looking at how much space we had between the coils after we layered it. And this is actually the finished CAD drawing because we were able to make this work. So that design was done. So here we are, it's in its new shaft, and it's got the old rotor coils. Now those coils have to be removed. They were removed off the spider. So this is what the spider looked like, and this is a point that I made earlier. I should have had this picture. Here's the shaft at about 16.25 inches that went into that spider, and then see that distance to the bottom of the dovetail. Those are the things I was worried about in the design. If we continued to bore this out, we were going to lose mechanical integrity, and that's what that other design assessment told us we were going to be okay with. So the coils were made, coils are mounted, the poles were stripped of their copper windings, and then simply this rotates and the wire gets fed on, and the guy is taking this wet epoxy compound and we're wet winding it as it wraps around layer by layer until it gets to the size and shape that we need. This is what it kind of looked like at the end, clamped, baked, and finished without any painting. And I'm jumping because I didn't have enough time. All the poles then were mounted back on with the new coils. So this is what the rotor looked like then with the new rotor design. Again, see how close we were getting to that shoring ring. But it all worked out. Keep in mind, everything had to position just right. The slip rings I couldn't just mount anywhere, right? I had to duplicate where they were originally. And I say the help of many, many guys and people like these guys sitting in here supported and figuring this thing out.